So this is the second part of the parallelograms section, so section 2 of unit 7. I went ahead and, just to make this video a little bit quicker, I went ahead and filled in some of the parts ahead of time. So if you need to pause, fill all this stuff in, please do, and then I'll explain it. So we can prove that parallelograms let me rephrase that. We can prove a polygon is a parallelogram by using points in a coordinate grid. So there's 3 different ways we can do this. Method 1 is we can prove both pairs of opposite sides are congruent. So what that means is if, say, side AB is congruent to side CD and side DA or AD, whichever, is congruent to BC, then ABCD is a parallelogram. Okay. When we're dealing with a coordinate grid, however, how we would find the lengths of those sides is by using our distance formula, which it's on the poster in my room up above the whiteboard on the left side. So if you need it there, you can use it up there. So it's the distance formula. I also wrote it here, so if you need to take a second and copy that down, you can. So the distance between 2 points on a line is this formula here. Okay. So that would be how we can prove that both pairs of opposite sides are congruent. Method 2 is we can also prove that both pairs of opposite sides are parallel. So what that's saying is if we can prove that side AB is parallel to side DC or CD, and we can prove that side AD is parallel to side BC, then we can prove that ABCD is a parallelogram. Okay? And so how we would prove that is we use our slope formula. So you have to think back to Algebra 1. The formula for the slope of a line is m equals y2 minus y1 over x2 minus x1. So the slope between 2 points on a line can be found using this formula. And so you use this to find the slope of each of these sides. If then AB and CD are parallel, and then BC and AD are parallel, then this shape would be a parallelogram. The last way, method 3, is if we prove one pair of opposite sides is congruent, and then, or one pair of opposite sides is congruent and parallel. So we can do this by proving that AB is congruent to DC or CD, and AB is parallel to CD. So if those 2 things are true, then ABCD is a parallelogram. And so in order to do that, we combine them together. We use the distance formula to find out if they're congruent, and we use the slope formula to find out if they're parallel. So let's try an example here. Now I went ahead and filled some pieces in because, especially with distance formula and slope formula, because we've seen these. We've seen the distance formula clear at the beginning of the year. We've seen the slope formula since Algebra 1. So pause when you need to, fill in what you need to. I kind of color-coded everything so that hopefully you could see what, or you could follow along with me. So, on number 1, we're going to use the distance formula. So we're going to use method 1. So I went ahead and drew my little parallelogram down here, or my shape, I guess, that I'm trying to determine is a parallelogram. So I need to try and prove that AB is congruent to CD and that BC is congruent to AD. So I'm going to look at AB and CD at first. So I need to find the length of those. I do that by using my distance formula. So I went ahead and set up here is the formula for AB to find the distance of, or the length of side AB. Okay, so I'm going to go ahead and work that out. So 7 plus 1 is 8 squared, which is going to give me 64, plus 2 minus 4 is negative 2 squared, plus 4, which gives me the square root of 68. You can just leave it like this. Don't bother getting some decimal out. Just leave it like that. Okay, now I want to look at CD. So I have 1 minus 9. I'm using these 2 points up here. I have 1 minus 9, which is negative 8 squared. That's 64. And then I have negative 6 plus 8, which is 2 squared, which is 4. So I end up with the square root of 68 as well. So since these are congruent, we're on the right track. However, we have to prove that both sets of opposite sides are congruent. So now we need to look at side AD and side BC. So for side AD, I'm using points A and D that I color-coded there. So 1 plus 7 is 8 squared, which also gives me 64. And then negative 6 minus 4, which gives me 10. So 10 squared then is 100. So the length of side AD is the square root of 164. All right, and then I do the same thing lastly with side B. So 9 minus 1 is 8. So 8 squared is also 64. And then negative 8 minus 2 is 10. 10 squared is 100. So again, now I'm going to draw a line here to separate these. So these two sides are, in fact, congruent. So since side AB is congruent to side CD, and side AD is congruent to side BC, this shape, or ABCD, is a parallelogram. So we just proved that AB and CD are congruent, and AD and BC are congruent. That's what we did up here. And because that is true, that makes this shape ABCD a parallelogram. Okay, you go ahead and try 2 on your own. I'm going to go ahead and move on to number 3. Again, I filled some of this in ahead of time. So I went ahead and drew my shape, my parallelogram over here. W, X, Y, Z. On this one here, I'm trying to prove, determine whether this this shape is a parallelogram using the slope formula. Okay, so that means I am trying to prove that WX is parallel to YZ and WZ is parallel to XY. So I'm trying to prove that WX is, it's not congruent, is parallel to YZ and WZ is parallel to XY. Okay, so I need to find the slopes of all 4 of those lines. So I went ahead and set up my slope formula over here. So for WX, I'm taking my points W and X. I am plugging those values into my slope formula. So negative 6 plus 4 gives me -2. And then 1 plus 7 gives me 8, which I can then simplify down to -1/4. So the slope of WX is -1/4. Then I want to look at YZ. Okay, and I'm using these 2 points now. Try and find the slope of the line connecting those 2 points. Okay, so -12 plus 13 is 1, and 1 minus 5 is -4. So these two are equal, they're the same. So we know for sure that WX is parallel to YZ. So now we got to move on to this point, these two lines. We need to see if those two lines are parallel. And so we do the same thing. So WZ, I have my values already plugged in. I'm using W and Z here. All right. Again, feel free to pause at any time. I know I'm kind of going fast. I just want to make sure this video is slow because some of you guys get to move in faster than others. So -12 plus 4 is -8. And 1 plus 7 is +8. So the slope of this line is -1. Okay. Then I need to find out the slope of line XY. So put in my slope formula. -13 plus 6 is -7. And then 5 minus 1 is 4. Okay. So these two slopes are not equal. So that means that WZ and XY are not parallel. So that does not work. So since even though one of the sets of opposite sides is parallel, the other is not. So So WXYZ is not a parallelogram. Since both sets of opposite sides were not parallel, then it is not a parallelogram. Okay, so that's step 4. Let's move on to number 5. Okay, so now we're going to determine whether this is a parallelogram using method 3, which is combination. So what we're trying to prove here is that line JK is congruent to line ML and JK is parallel to ML. So I'm trying to prove, if I look down at my shape down here, I'm trying to prove that these are congruent and that they're parallel. So I went ahead and set up my 2 sets of information I'm trying to find. So in order to find out if JK and ML are congruent, I need to find the distance between J and K and the distance between M and L. I need to find the lengths of those 2 sides. So that's where I set these up using my distance formula. So you can go ahead and work on solving that. And I'll kind of let you guys run wild with that since we did just the distance formula on the front page. And then in order to find out if JK is parallel to ML, I need to use my slope formula. Okay. So that is the rest of the parallelogram section. So go ahead and do the evens 2, 4, and 6 on there. And then you have an assignment to work on. And then you can move on to the next set of notes. So make sure that you watch both parts of section 2.